Alright, so our unit learning target 1, we have 2, we're going to have a couple of unit learning targets, but our first one that we're going to do is we're going to be able to find the solutions of a quadratic function using its graph. So that's one of our main goals. First, we have to learn how to graph a quadratic, and today we're going to learn how to graph a quadratic using a t-table. Now, a quadratic function is a function with a degree of 2. That means that its highest exponent is 2. So isn't that like what we've been factoring? Yes, so we've been factoring x squared and 3x squared. So today we're going to learn how to graph it by using a t-table. Now a parabola, which is the next word we're going to learn, and it's not parabola, it's parabola. It's the graph of a quadratic. Now the graph of a quadratic can look 2 ways. It can open up or it can open down, and it's always going to be a U. On your quadratic, on your parabola, you have a vertex. It is the highest or lowest point on the graph. So again, it can look 2 ways. It can look like this, where it opens up, or it can look like this, where it opens down. Now, this quadratic on the left has a ham sandwich. Its vertex is the lowest point, so it's called a minimum. The quadratic on the right, it has the highest point, so what's that going to be called? Maximum. Take a point.
We did something like this at the old school, right?
Ish. Now, the point of today is not only to be able to graph, but to identify the solutions. Solutions are a very important part of a quadratic. That's what we've been factoring, that's what we've been finding, but when we graph it, it's where the graph crosses the x-axis. And when it crosses the x-axis, your y value has a very important value. Y equals 0. So when you're looking at your t-table, you're going to look for your y value that's 0. That's one of your solutions. Or if you're just looking at a graph, you're going to see where it crosses the x-axis. So the pink one, the one on the left, how many times does it cross the x-axis? 2. So we have 2 solutions. This is x, this is y. The dark pink one, how many times does that cross the x-axis? 2. So it has 2 solutions. Do you see how it crosses the x-axis? That's your solution. And it crosses twice. That would be the y-intercept. The y only crosses once. Alright, now solutions have 3 different names. They are known as x-intercepts. They are known as roots, and they are also known as zeros. So if I ask you for the x-intercept, what I'm asking for is where it crosses the x-axis or where y equals 0. Same thing for roots, same thing for zeros. And it can have 2, 1, or no real solutions. Yes.
Is this the first time we talked about x intercepts? We always talk
No.
about y.
But it's the first time we've talked about x-intercepts as solutions. We have talked about x-intercepts before and we found them, but this time they're solutions and have a meaning in our problem, and not just a point on the graph.
I got you.
All right, so we're going to come back and fill these in tomorrow because I have a meeting at 2 and I want to make sure we get our lesson so that you can do your homework. So please go to the next page. All right, so now we're going to actually figure out how to graph these quadratic functions. It says to plug in -2, that should be a -1, I got excited. -2, -1, 0, 1, and 2 for x and get your y values. So it's just like how we first learned to graph a linear equation where we just plugged in our x values and got our y's. So in our x column, it's -2, -1, 0, 1, and 2.
Have I done this before?
Yes, but not for a quadratic. This particular quadratic is one of the most important functions. It is called the parent function, and it is very important that you know that that's called the parent function because I'm probably going to ask you what's the parent function of a quadratic. It's y equals x squared. The parent function of a linear is y equals x. Just a fun fact there. Not of a linear, but it is of a quadratic. All right, so now you plug it in. So what is -2 squared? You're pre-AP. Let's try again. What's -2 squared? 4.
2.
What's -1 squared? What is 0 squared?
0.
What is 1 squared? 2 squared? Now it says, what do you notice about the y values?
They're all positive. They're all.
They repeat. Take a point. Now, which one doesn't repeat? That means that this one right here is your vertex.
How does it not repeat? It's right there. It doesn't repeat on the last side.
The y side.
Can we make that? It only shows that once.
We're going to write it at the bottom.
Oh, okay.
Yeah.
Because we're going to need to know that. All right, so let's plot. You go left 2, up 1, 2, 3, 4. Left 1, up 1, 0, 0. Right 1, up 1. Right 2, up 1, 2, 3, 4. And a quadratic always makes a U, not a V. A U, not a V.
So if this is
It is very important you know that.
Where would you like?
A V is a an absolute value quadratic. It's a U, not a V. Does everybody understand? It's a U, not a V.
Got it. Is that good?
That's beautiful.
accidentally make a V.
Then I'm going to count off.
Is that a V?
That's a U. A V has a sharp point at the end. All right, so now let's look at y equals -x squared. We're still going to plug in the same numbers. -2, -1, 0, 1, and 2. But this negative is going to change our output. So when we square -2, we get 4. But what is this negative going to do to it? Make it a -4. Does everybody understand? Okay? When we square -1, we get 1. But what does the negative make it? Okay? Is 0 going to be -0 or do we just get 0?
0.
Good. And then 1 squared is 1, but what does it become because of the negative? And then? Awesome. What is our vertex?
0. Is it ever going to be something else?
Yes.
Okay.
All right, so the vertex is the coordinate that doesn't repeat. What is this also called?
The maximum and the median.
What did we write on the front where we said y equals 0?
Parent function.
No, on the front. The first page.
2, 1, 3.
The solution. So not only is this our vertex, but this is our solution, and that's a point. So we're going to go left 2, down 1, 2, 3, 4. And I'm going to prove it to you and show you how. Left 1, down 1. 0, 0. Right 1, down 1. Right 2, down 4. Now the solutions are where it crosses the x-axis. So how many times does this cross the x-axis? One time. So this is our solution. It is our solution. It is our vertex. And is it a maximum or a minimum?
Maximum.
Maximum, because it is the highest point.
Can it also be called other stuff? I don't like it. Oh, wait, no.
That was just your intercepts.
Oh, I got you.
That was your solutions. Are we ready?
Wait.
Hustle up.
Huh?
Okay.
So the maximum of whatever is 0.
The maximum of this graph is 0.
Yeah.
0, 0. Now, do you see how this is a negative?
Oh, yes.
That means it's going to open down every time. Our parent function was a positive, so it opened up. That's going to be the same every single time. Now, let's go to where they're a little bit more complicated.
What was the maximum before?
Because it's the lowest point of that one. Because it opens up. Alright, so what you do is you, like it says at the top, you create a table of values for the quadratic function by plugging in numbers for x. Then you plot the points on a graph and carefully connect them, identify the solutions. So what we're going to do is we're going to write x squared minus 2x minus 3. And everywhere we see an x, we're going to plug in these values. And we're going to work them out line by line. Does everybody understand? Now, it helps a lot of times if you have a process column, and that's what we're creating. So we're going to plug in negative 3. And we're going to get negative 3 squared minus 2 times negative 3 minus 3. I'm sorry, what was that, Cletus?
How do we do that?
Okay, how do you see where we have x's? And what does x equal? So negative 3, so that's what we plugged in. Okay, so negative 3 squared is 9. What is negative 2 times negative 3? What's 9 plus 6? 15 minus 3? So Cletus was right. Does everybody see how we got 12?
Yes.
Okay, now we're going to go to the next line.
It's 9.
So we have negative 2 squared minus 2 times negative 2 minus 3. Does everybody see where we got the negative 2's from?
Yes.
Are we sure? Okay, so we're going to do negative 2 squared and we're going to get 4. Negative 2 times negative 2 is?
4.
So 4 plus 4 is?
8.
8 minus 3 is?
5.
Alright, for negative 1. Now, it is not going to automatically repeat at 0 like our beginning problems did. So do not think that just because it's 0, that means it's going to start repeating. That's not how it works. Alright, what is negative 1 squared? And what's negative 2 times negative 1? What's 1 plus 2? 3 minus 3 is? Yes.
Why don't you add those two? I meant like I subtract them.
Which 2? There's 72 numbers
I
in there.
meant, when you multiply or square.
Okay, negative 1 squared becomes 1. Negative 2 times negative 1 becomes positive 2 minus 3.
That equals
Right here, it's 4 plus 4 minus 3. Right here, it's 9 plus 6 minus 3. Yes.
Do we do PEMDAS when we do it now?
Yes.
Yeah, okay.
All right, now let's plug in 0. Oh, ham sandwich. Now, do you have to write this process column every time if you can do it in your head?
Yes.
No. But it's going to help. All right, 0 squared is?
0.
2 times 0 is? 0 minus 0?
Negative
0 minus 3? All right, let's plug in 1 super fast because I got to go to my meeting. It's vamos.
Oh, I thought it was a Venus.
All right, what is 1 squared?
2.
No, guys, you're pre-AP. What's 1 squared? What's negative 2 times 1?
Negative 2.
All right, what's 1 minus 2?
Negative 1.
And what's negative 1 minus 3?
Negative 4.
Have we started repeating yet?
No.
All right, fantastic. So have we found our vertex yet?
No.
No. Let's plug in 2.
I thought it was when the Y repeated.
Has the y repeated yet?
Oh, I did all the problems. That's why I never mind.
So you've already worked ahead?
Yeah.
Okay.
Yes, ma'am.
Good job, Papa. Thanks. I didn't say it.
All right, what's 2 squared?
4.
What's 2 times 2?
4.
All right, what's 4 minus 4?
0.
What's 0 minus 3?
Negative 3.
Boom. So that repeats. All right, so what's our next y value going to have to be?
0.
0. And if I plug in 4, what's my y value going to have to be?
5.
5. It keeps going, guys. All right, so what's my vertex?
3.
No, what's my vertex? 1, negative 4 is my vertex. And what are our roots? Look back at the first page where we talked about roots. What did we say?
Negative 3.
Which one?
Is that the vertex?
No. Wait, why would
Because it's the y value that doesn't repeat. Remember, the vertex is the one that doesn't repeat.
Oh, okay.
All right, what did we write on the front about roots? Look back at the first page.
we said root solutions
It's
are
the
also
one.
What did we say about those? We defined it. And where y equals 0. So this is the root, and this is the root. Your homework tonight is to graph 1 and do 2, 3, and 4. If you need help, come to 0 period. Yes. Tell me super fast, baby. I have a meeting like right now.
Don't be on phone.
The one that repeats.
What do you mean, honey?
I don't.
Come on, baby. Like, I gotta go.
I don't understand.
What part, honey?
You said it repeats.
Okay, the y values. Baby, do you see how we got to negative 4 and then our next y value is negative 3? Do you see how that's also negative 3? That means it starts repeating. So then it's going to become 0, and then it's going to become 5, and what would the next one be?
But then negative 4 will never repeat because it's already past negative.
Because it's a vertex.
It's easy, you just don't be dumb.
Logan.